If you've been hanging around this channel very long, you've probably heard me mention just how hot this shop can get. It's that time of year again. It is so hot up here. I got the fan blowing right on me. That's the actual sweat that was dripping off of me. I had to take a shower in the middle of the day. I've got to turn the fan on, by the way, because it's super humid today. It's 100 and balls degrees in here. That hum you've been hearing in the background of my videos lately, that's my air conditioner. And, well, up to about 90 degrees outside, it keeps it fairly comfortable in here. But I live in North Texas, and it's lately gotten up to about 108. If you're watching this from the future, it was only 108 this week. So in the middle of the day, it can reach up to about 90 degrees in here. And the biggest reason for this? This giant door. I said metal. Giant metal door. I don't know why you'd have to... Okay. The rest of the shop is insulated with spray-on foam, but this bare steel door, which faces almost due south and catches a lot of sun, well, it's basically a giant radiator. In fact, I've clocked it at over 120 degrees. Now, I have finally decided to do something about it. So we're going to do a science. I'm testing 3 different materials and combinations thereof. Got my science glasses on, by the way. This extruded polystyrene sheet, 1/2 inch, which you can get at the big box stores. This highly reflective mylar, which I got on Amazon. And this radiant barrier material, which is basically the same thing, but with bubble wrap sandwiched in between. This is my control. These are basically miniature versions of panels I plan to install inside the roll-up door, and I've come into the house to test them because the inside of the shop is still in the upper 80s. So if I were to measure the backs of these out there, they would never read below that, which isn't going to tell me very much about how effective these are. So I have moved into the proper air conditioning where it is a cool 70 degrees. So with the temperature outside currently at 103, our control reads, and I'm going to round these off to whole numbers, 102, yeah, not much protection from that wood. Polystyrene is 81, the mylar 86, and the bubble wrap radiant barrier 82. Of course, the actual panels are not going to be exposed to the open air like this. They're going to be blocking the heat radiating off the inside of the door. So I cut myself a couple of mock doors from some steel sheet, painted one side white, one side gray, just like the real door. And after waiting for the temperatures to stabilize, it gives us 89, definitely a difference on the control. Polystyrene, 78, mylar, 81, radiant barrier, 79. Okay, next up, I'm going to try the 2 metallized sheets with 1/2 inch foam behind them, and I'd also like to find out what kind of difference the 1 inch makes by itself over the 1/2 inch. All right, our control is at 86, I think it was 89 before, I guess that's within a margin of error. The 1 inch XPS, 73. The 1/2 inch plus mylar, also 73. And the 1/2 inch plus bubble wrap radiant barrier, also 73. Wow, these are all almost exactly the same. Okay, another result. So it looks like the 1 inch by itself performs the same as the 1/2 inch with the radiant barriers. And by the way, the plain mylar and the bubble wrap type sheets are both marketed as radiant barriers, so sometimes I might refer to them together as such, just in case there's any confusion. Now, as one last test, let's try the 1 inch with the silver stuff. I might also refer to it as the silver stuff. And with the control maintaining 86, the 1 inch still at 73. The 1 inch with Mylar, only about a degree's difference, and the bubble wrap Mylar, same. So no real difference between these two, and only a degree's difference with the plain 1 inch. All right, feels good to do some science. However, we'll go over the data in more detail a little later. For now, let's start making something. The vertical parts of these panels are almost 10 feet long, which is a little difficult to cut a half lap into the end of on a crosscut sled when you've got like 8 feet hanging off the end. So instead, I am using my new favorite toy, the X-CARVE Pro. Is it overkill? Not when you like your fingers. And I figured while I was at it, may as well do the hinge mortises too. Concrete foundation. Nature's workbench. This side is the back. Use other side. Who is revolution? Apply to tell me what to do. Revolution. You want a revolution? I'm using this as the front. Here's your revolution. That's all right. I'm revolting. Wait.
So, if that looked to you like it went together a lot easier than it should have, well, you're very smart. But how much cursing and shimming do you really want to watch? If the answer is a lot, head over to Patreon, because that's where all the extras go. But for now, let's review some data. If you aren't interested at all in a breakdown of the data, by the way, you can skip to this time code. If you're a fan of Matthias Wandel, however, maybe stick around. My data isn't nearly as thorough, and I don't have a Canadian accent, but my test beds are made of wood, and I'm almost as adorable. So, My initial tests showed that the bubble wrap Mylar by itself resulted in a 10-degree difference over the control, which was 2 degrees better than the plain Mylar, which isn't much of a surprise considering the additional layer of air provided by the bubbles. However, the half-inch foam by itself outperformed that by an additional degree. I gotta warn you, the results of these tests aren't that dramatic. Not nearly as dramatic as I'd hoped. We're talking only a few degrees here. The half-inch combined with the radiant barriers gave us only an additional 2 degrees improvement, both types of Mylar performing the same. It seems that the bubbles don't really add much when you've already got a layer of foam behind them. And as you saw, the 1-inch foam performed identically to those. The 1-inch combined with the radiant barriers, however, gave us an additional 1 degree difference. I went back and tested most of these materials more than once, by the way, especially since I was concerned about that 89 to 86 degree change in my control early on. I think that may have been due to a cloud passing by and casting a shadow on my samples. Now, since both thicknesses of foam performed better with the radiant barriers, I concentrated mostly on those. And after averaging the results, the winner is the 1-inch foam with plain Mylar at an average of 12.4 degrees improvement, only marginally better than the bubble wrap Mylar at 12.2, a difference probably due just to noise. The half-inch foam with the plain Mylar fared only slightly worse at 11.8 degrees difference. Now, keep in mind, while 12 degrees difference doesn't sound like a lot, that's a difference from the control, which was a box simply with no insulation in it, whereas the metal covers in direct sunlight were measuring between 120 and 130 degrees. That's a 30 to 40 degree improvement with insulation. A huge difference when you're standing behind that metal. Also, these results should not be taken as definitive and should not be applied to choosing insulation for your home. This was a specific scenario with only a handful of measurements. So, in conclusion, if price were a factor in choosing materials, I'd probably go with the half-inch foam, seeing as there would be very little loss in improvement over the 1-inch. However, things being what they are right now, in the summer of 22, the half-inch and the 1-inch are currently being sold at the exact same inflated price. So, I have opted for the 1-inch. And yes, you can get foam board with the Mylar already attached, but around here, at least right now, I could only get expanded polystyrene, which is the stuff coffee cups are made out of. It's not as good an insulator, and, well, I just plain hate the stuff. Whenever I pull out this tool, people ask me what it is. It is a framer's point driver, and it is one of my favorite toys. There is a link to it down in the video description. I seem to have made a fun house. Oh, okay. Yeah. You know, I wasn't sure exactly what kind of an effect these were going to have, but I can tell you, just standing here, I can already feel a difference. I didn't cool down the whole shop instantly, of course, but it no longer feels like I'm standing in front of an open pizza oven on this end of the shop. Okay, I'm going to leave these up for a while, wait for the hottest part of the day, and then get a reading off the backs of these. In the meantime, let's add some finishing touches. I kept going back and forth on what kind of finish I was going to use on these panels, but decided I like the wood. Warms it up a little in here. So I'm just going to give them a clear coat. Once again with Total Boat's Halcyon Clear, same thing I used over on my alternating steps in my last video. It's water-based, super easy to use. I was trying an undercoating technique there with the black. You spray on the top coat, depending on how opaque it is. It can appear darker around the edges, a little brighter in the center, gives it some shading. Worked okay with the orange in this case, didn't really work with the other ones, so I just gave them all a second coat and forgot about it. That is gonna work great! Is it perfect? No, it's not. For perfect, I'd have to seal up this entire door, but I can't seal up this entire door. I hate this door, but I need this door. It's a dysfunctional relationship. But how well does it work? Well, I just measured the inside of the metal at 4 p.m. in full sunlight at almost 106 degrees. What is it in here? And for the nerds, yes, I did change the emissivity setting for the different materials. "78 degrees. Yeah, that's a result I can live with. And it makes a nifty background. Now, I had set up a couple of Raspberry Pis, one outside, one here in the shop, and I was tracking the temperature data, hoping to show you guys a clear before and after. But unfortunately, as I was finishing up this project, we've had storms roll through and completely screw up my data. However, if you follow me over on Instagram and it gets up above 100 again, then I will probably post the results over there.
And before the contrarians come in and tell me I wasted all my time, that I could have just attached radiant barrier directly to the inside of the door, yes, there are plenty of videos here on YouTube that show you how to attach this sort of thing using magnets or sometimes glue directly to the inside of your garage door to insulate it. And I don't doubt that they do see some result. However, for a radiant barrier to work properly, there must be an air gap, a space between itself and the heat source. That's why I've left about 3/4 of an inch in the back of these panels, about the minimum recommended. I'll link to a source or two below that explain it better than I can. Thank you to X-CARVE for sponsoring this video. If you're looking at buying an X-CARVE for your very own, use that link down in the video description. It'll help me to keep making more videos. Also, shout out to TotalBoat for providing the Halcyon. This satin finish is perfect for this background. Questions, comments, leave them down below. I will do my best to answer them if I'm not already dead, because apparently the stairs I just built are gonna kill me.